So there were aqueducts that were already bringing in water into the Chestnut Hill
That's right.
reservoir
That's right.
even
The very
before
first
this building.
aqueduct was put in 1848. That was from Lake Cochituate out in Natick.
Right.
And so that was actually here. Also, the reservoir right outside the window here was built somewhere between the end of the Civil War and 1870. So that was here. And one of the parts of the city that was really growing the fastest were the higher elevations of Boston. That was parts of Dorchester, West Roxbury, even Beacon Hill. Oddly today, the wealthier inhabitants tend to like the higher areas, but back then it was the newer citizens that were asked to live in the higher locations.
So if you're going to move some water from the Chestnut Hill Reservoir up to the Dorchester Heights, you got to have something to pump it.
That's exactly right. So in 1887, this site was built, intended as a state-of-the-art pumping facility. There were a number of supplies, water supplies at that time, and aqueducts. So it wasn't at the beginning of the formation of the system. It was really, I'd say, when it became modernized. So by great fortune, one of the most innovative steam engineers of his day, Erasmus Darwin Leavitt, figured out a way to make a pump double the capacity of the other two pumps. And he was actually working in Cambridge at the time, and it had an enormous amount of experience in customized pumping engines. And that's the key here, because the only way to make this happen was to actually install it at an angle. So part of it is sort of down in the ground, and very unusual. It's a unique piece of equipment. It was amazing that he was able to do that. He added a few twists that were very cutting edge, one of which was to make the speed of that engine much faster than a normal pumping engine.
How many millions of gallons could this?
Well, this one would be 20 million gallons.
Wow, so huge
but
increase.
But the speed, which is the revolutions of the flywheel, essentially, would normally steam engines move very slowly, very stately. If you ever see them in operation, it's about 30 revolutions, 35 revolutions a minute. His was 50. So it was really racing in order to pump more water. The system was absolutely overwhelmed by demand. Another massive wave of immigrants had come in, and it was felt finally at that time the legislature decided, okay, well, we need to then now expand the building. And we need to put in the biggest possible pumping engine with the most capacity that we have available. And so at that point, engine number 4, this one behind me here, the Alice Chalmers engine, was installed, and it was built while the addition was put onto the building. So if you look above, there's a giant bridge crane that brought many of the massive components in through the windows, essentially, as it was being built around it. And that new engine added 30 million gallons a day. So
this massive Alice engine behind us.
Behemoth of an engine, and it was quite a bit different than Erasmus' piece. Erasmus was sort of, as I mentioned, reacting on the fly, building it as best he could in a situation that wasn't ideal. The Alice engine, on the other hand, was exactly how it was envisioned, and it was at the beginning of sort of the manufacturing franchise concept. So that giant engine came in pieces on the railroad here. It came with its own engineers and instructions, and they monitored it as it was put together and made sure it functioned in full capacity. The Worthington engine is particularly interesting. Now, this comes after World War I, and you can see it's enormously different in many ways from the other two engines. Not only is it not a triple expansion vertical engine like the other two, it's a horizontal dual expansion engine, but it's quite a bit smaller. What it does have is it's refined to the point of incredible simplicity and excellence. There were thousands of these types of engines that were any city or town could buy them to pump sewage or water, easily install them.
So we've moved from the highly bespoke, tailor-made Leavitt engine to an era of mass producing these behemoths.
And the mass production is exactly the key. There's not much flair to it. It works great, and it's a production piece. But it's all about the money in the end. It's no superfluous expenditures. And the irony of it of all of that is that the steam age really ended right about the time that engine became perfected and easy to get.